The second type of projectile motion question, just making it one step more complicated, is if I give you an initial vertical velocity for a projectile. We're still ignoring any horizontal travel, but if I give you an initial vertical velocity and say how long does it take to hit the ground, we can now do stuff with that. Let's take a look. In this case, I have a golf ball that's launched straight up from the ground with a velocity of 13 meters per second. So this is a vertical velocity. I'm going to say that's my initial vertical velocity right here. So I'm going to write that down, is positive 13 meters per second. I did put that as positive because it's being launched upwards. So if I have this projectile here, this ball, and it's being launched up with my initial vertical velocity, I'm asking for how long will it take the golf ball to hit the ground? How long is a time? So I'm looking for a time. And I also know that my vertical acceleration is negative 9.81 meters per second squared. So I have two ways that I can do this. Using an algebraic method, I can solve this when I realize that at the top of the arc, at the apex of this path, the vertical velocity is 0. So if I have a ball and it travels up, and then it travels back down, right at the very top of this path here, my vertical velocity is 0 at the apex, or the highest point of that path. Knowing that, I can do a little bit of figuring here. So if my vertical velocity at the end of the first part, so I'm just considering the up part, so when the projectile goes up to the top of the path and stops there, the vertical final velocity of that part is 0, so I can find my delta V, which would be 0 minus 13. So my delta V is negative 13 meters per second, which makes sense. I slowed down by 13 meters per second. Again, remember your delta V is always your final minus your initial. Knowing that, I can use a simple formula. Delta V is my acceleration times time. This is a grade 10 formula, V equals AT. So I can go negative 13 is negative 9.81 T. You have to be careful with our negatives. These will cancel out, which is good because my time will need to end up being positive. So in this case, my time is 1.325 seconds. This is the time it takes for the ball to go from launch to the apex. Okay, so this is launch to apex time, or in shorthand, I like to call this T up, how long it takes to go to the top, or how long it takes to go up. This here is launched from the ground. See here, I'm launched from the ground, and it is returning to the ground here. So my time up, or my distance up and my distance down are exactly the same, which means my time up and my time down are the same. Because I'm returning to the same height, T up is equal to T down. So my T total is going to be 1.325 times 2, which works out to 2.65 seconds. Okay? This T up is equal to T down. This we can do because we launch and land at the same height. This is one way to solve this. Because I happen to know that my vertical velocity is 0 at the apex, I can use this formula here to figure out my time up and then figure out my time down. There is another way to solve this, however. If your pre-cal skills are good, you can do quadratics. So if I look at this and say my distance is equal to 1/2 at squared plus bvi times t plus di. So plugging that in, I would get 1/2 negative 9.81 t squared plus my initial vertical velocity is 13 t, and I have no initial distance, so that's 0. And I can now find my zeros. If I find my x-intercepts here, or the zeros of this, this is going to be really difficult to factor because that's not going to factor nicely at all. But you could use quadratic formula, or if you want to check your mark or check your answer here, go use something like Desmos to graph this out. You can see what it looks like. This will end up giving you exactly the same answer as this when you figure out what your zeros of this graph are.